Hello, and welcome to the AI Research Roundup. I am your host, Alex. It is May 11th, 2025, and today we are diving into a research paper from Hugging Face's trending list, published just 11 days ago on April 30th. It is titled, Which Agent Causes Task Failures and When? On Automated Failure Attribution of LLM Multi-Agent Systems. This paper explores how to automatically pinpoint failures in systems where multiple large language models, or LLMs, work together. This process, called failure attribution, which means identifying the specific agent and the decisive error step responsible for a task failure, is vital for debugging, but currently very manual. To help, this paper introduces the Who&When dataset. Alright, so this first figure really sets the scene. It shows how an LLM multi-agent system, that is, a system where multiple large language models work together, tackles various tasks. When things go wrong, they produce failure logs, which are just records of the errors. The diagram then contrasts the old way, manual failure attribution, which is costly and needs experts, with the goal of automated failure attribution. The automated approach aims to efficiently identify not only the responsible agent, but also the decisive error step, the exact point where the critical mistake happened, without needing human experts. Alright, building on that need for automation, this next figure really underscores why. It presents a statistical analysis of the manual annotation process. That is, the human effort to label these failure logs by identifying the responsible agent and the exact error step. So we see in part A that the annotation labor cost, in hours, is quite high. Then, part B shows a significant percentage of these annotations involve uncertainty from the labelers. And finally, part C reveals considerable disagreement rates between different human annotators. All of this really drives home how challenging manual failure attribution is. So, to tackle these manual annotation challenges, the researchers propose and test automated approaches. This figure compares three distinct failure attribution methods. These are different strategies for large language models to find the error, using several types of large language models. We see two main measures, agent-level accuracy on the left, which is how often the correct agent is identified, and step-level accuracy on the right, which is how often the exact error step is found. The all-at-once method, where the large language model reviews the entire log at once, generally excels at agent-level accuracy. Meanwhile, the step-by-step method, which processes the log incrementally, performs best for step-level accuracy, although its overall success rate here is notably lower. Okay, so this table then details the performance of these three failure attribution methods. All at once, step-by-step, and binary search. When tested with the GPT-4o model on the Who&When dataset, it breaks things down by agent level and step level accuracy. It also shows results with ground truth, meaning when the model has the correct answers available for comparison, and without ground truth, and for different agentic systems types, specifically algorithm-generated systems versus handcrafted ones. Consistent with what we saw earlier, the all-at-once method scores highest on agent-level accuracy, reaching over 50%. However, step-by-step leads for step-level accuracy, though its best scores are still quite low, highlighting the difficulty in pinpointing the exact error step. So considering those individual strengths, the researchers then tested a hybrid approach. For the handcrafted systems, we see the all-at-once method is still very efficient, using the fewest tokens. These tokens are units of text or code the model processes, so fewer tokens mean less computational work. Now, this hybrid method, which blends all at once for finding the agent and step-by-step for the error step, achieves that same top agent-level accuracy of 57%. More importantly, it pushes step-level accuracy up to 12.28%, the best yet, although this combined strategy does require the most tokens. Alright, so while that hybrid method showed some promise, particularly for step accuracy, this next table broadens the scope a bit. It compares the all-at-once and step-by-step methods again, but this time across different large language models, specifically GPT-4o, OpenAI o1, and DeepSeek R1. We see that DeepSeek R1 actually achieves the highest agent-level accuracy using the all-at-once method. However, OpenAI O1 gets the best step-level accuracy with the step-by-step approach. Interestingly, this suggests that even models known for strong reasoning do not uniformly excel at both identifying the agent and the precise error step, and overall step accuracy remains a tough nut to crack. So, to wrap things up on this research, it is clear that automated failure attribution, which is all about identifying the specific AI agent and the exact step where an error occurred in these complex multi-agent systems, is still in its early days. The findings show that while large language models can get pretty good at finding the responsible agent, they really struggle to pinpoint that precise error step. This work highlights automated failure attribution as a critical but underexplored area needing much more research. That is all for this AI Research Roundup. Thanks for listening.